Hello everyone and welcome to tutorial number 47 in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. In the last tutorial I discussed about type wrappers, boxing and unboxing. Okay, I explained these concepts with the help of the IDE. So if you're interested in learning these concepts, then you can go and watch the last tutorial. So in this tutorial, I'm going to talk about the concepts of autoboxing and annotations. So let's get started. So first of all, I'm going to talk about the concept of autoboxing. All right. So autoboxing is a kind of automatic boxing, okay, of a primitive type in object of a type wrapper. Okay. So autoboxing basically it is the concept of boxing only, but it is going to be performed automatically by the Java compiler. Okay. So that is why I've written the second statement here that there is no need to create object explicitly. Okay, so here I have given the few examples here. Okay, and these are the concept of autoboxing. Like for example, here I have written integer I equals 100. That means I am storing 100 inside the object of I. Okay, inside the object of this integer. Okay, in much the same manner I am storing the 30.0f in object of the float, okay, which is a class obviously, and I'm storing 50.d in object of double d. Okay, I'm storing the value true in object of boolean, okay, whose object reference it is named by b, and here the value of 345 is stored in l. Okay, and I think I repeated this thing, boolean b equals true, which was already mentioned here. So after this I am storing the value of a inside c. I'm storing the value of 23 inside I, and 100 I'm storing the value of 100 after converting it to byte and then storing it in B. Okay, so one thing you need to remember is that this 100 by default it is always an integer. So first of all I need to explicitly cast it to a byte, then after that only I can perform autoboxing on it. Okay, so autoboxing is very simple actually. So you just need to write create the reference of the class, then equal it to the value, okay, value of the primitive, equivalent primitive. Like for example, here I've written integer, then the value should be, integer value should be provided over here. Here I'm writing double, creating object of double. Here I'm providing the double value to this particular object. All right, now I am going to talk about auto unboxing. Okay, so automatic extraction of a value from object. Okay, it is exactly the opposite of this auto boxing. Okay, whenever I am extracting the value, but it is happening automatically. Okay, from the object of the type wrapper. Okay, so here also there is no need to use methods explicitly. Okay, in unboxing, what we used to do earlier, if you remember, we used int value, we used boolean value, we used float value, etc. and all. But in auto unboxing, we don't need to use these methods. Okay, we use this simple. This third point is what we are doing in auto unboxing. Okay, first of all, the first statement which I've written here, integer I obj equals 23. Okay, obviously, you would have know by now that this is, auto boxing. Okay, this is not auto unboxing, this is auto boxing. Okay, and int I equals I obj, this is auto unboxing. But the reason why I wrote the I obj here is because I wanted to show what is the data type of this I obj. Okay, so this int I equals I obj, this is known as auto unboxing. Okay, I am extracting the value which is stored inside this I obj. Here in this example, the value stored in I obj is 23. So ultimately the value which is going to get stored in the I variable, it is going to be 23. All right, so this is auto unboxing. Okay, so I don't need to manually use the methods explicitly. The Java compiler it is going to automatically do it. So these are the concept of auto unboxing and auto boxing. After that, I'm going to talk about auto boxing and methods. Okay, let us imagine that we have this particular method. Okay, so in this particular method, it is of static modifier. Okay, which means it can be accessed without creating the object of the class in which it is defined. Then after that we have the int data type. Okay, return type is int. M is the name of the method, and it is accepting the object of the integer class. Okay, reference of the integer class, or you can say object of the integer class. Then after this it is returning v. Now one thing to remember is that the return type of this particular method is int, and this int, it is a primitive data type, and this integer, it is a it is a kind of type wrapper. Okay, so that is why here it is automatically going to unbox to int. That is why whenever it is going to return the value v. Okay, v, it is a object of the integer class, right? But I want to return the primitive data type. Okay, so it is going to automatically unbox to int. Okay, int, which is the primitive data type, which matches with the return type. Okay, and in much the same manner here I can write integer I equals m100. Okay, in this particular statement return v, it is automatically unboxing. In this statement integer I equals m100, it is going to automatically box this particular value inside I. Okay, the value of 100, it is going to be boxed inside I. So that is what this particular method is going to do. Okay, so this particular method, it is going to perform unboxing, auto unboxing. And this particular statement integer I equals m100, it is going to perform auto boxing. All right, then after that we have auto boxing and expressions. So, whenever we are performing, auto boxing or auto unboxing of a particular object, okay, in a particular expression, like for example, here if I write integer I obj equals 23, then this is auto boxing, obviously. But if I write plus plus I obj, okay, then what I'm doing, I'm actually increasing the value which is stored inside the, the object of this particular type wrapper class. Okay, this object of the type wrapper class, it contains the value 23. So whenever I'm writing plus plus I obj, what is actually happening behind the scenes is that first of all the value which is present inside this object, first of all it gets unboxed. Okay, then after that the value is incremented. So then after that it becomes 24. Then the value 24, it gets stored inside IOBJ. Okay, so it gets boxed once again. So that is how this particular auto boxing in expressions is going to work. Then after that, okay, so this was the concept of auto boxing and auto unboxing. Okay, so now we are going to start a completely new concept which is known as annotations. Okay, so annotations are a kind of a metadata about a program. Okay, so that is what we call as annotations. Okay, if you have studied C sharp, okay, if you are proficient in C sharp, then you will know that C sharp contains attributes. Okay, so this Java contains annotations which is just similar to attributes in C sharp. Okay, so it is just going to add some metadata about a particular class or a constructor or a particular method or a field, etc. Okay, so you need to remember that this annotation, it is not going to change the semantics of a program. It is not going to change the like let us say I'm writing a program for finding out whether a number is prime or not. It is not going to change either the semantics, or it is not going to change the logic for the prime number. Okay, it is only going to add the metadata. All right, and this particular annotation concept of annotations, it is based on interface. Okay, so if whenever you are trying to declare an annotation, we are going to do this particular thing: at the rate interface my annotation. Okay, at the rate interface, this at the rate is very very important, whenever you are declaring an annotation, because if you don't write at the rate, then it will a compiler will assume that you're trying to define an interface. But if you're writing at the rate, then the compiler, Java compiler, it will understand that okay, you're not trying to define a interface, rather you're trying to define an annotation. So this at the rate is very very important. First of all, you need to write at the rate, then you need to write interface, then after that the name of the particular annotation. All right, so here I've written my annotation. Then obviously the annotation, this particular thing, it is an interface, so it is going to contain a few methods: string str, okay, semicolon, int val. Okay, and one beauty about the annotation is that you know even though this is a kind of it is a based on interface, you don't need to provide bodies for the methods, because ultimately you're not going to implement this particular annotation. Okay, what happens in the concept of interface is that first of all we define an interface. Okay, then after that we write the methods, abstract methods inside it. But here we are defining an annotation, which is defined by other rate interface. At the rate interface, then after that interface name, then after that we have this particular methods inside it. So there is no need to provide bodies for this method, because because these methods, okay, they are defined inside an annotation, and we are not going to suppose, we are not going to implement an annotation. Okay, and another thing which you need to remember is that annotation, they cannot include extends keyword. That means an annotation, it cannot extend from another annotation. Okay, but however you need to remember that there is a base class for all annotation. Okay, and the name of that class is name of that particular interface is annotation itself. Okay, so it is going to act as a base for all the annotations. And annotation can be annotated. Okay, we can add annotation on annotations. Okay, so these are the few things about annotations. Then after that we have the retention policy. Okay, so in Java programming language, you can discard the annotation. Okay, when I talk about annotation, I'm talking about metadata about a particular, okay, whether it is a variable or whether it is a class, okay, or a method, constructor, etc. So whenever I want to discard that particular annotation, okay, that is going to be determined by the retention policy. Okay, so in the Java programming language, there are three policies. First of all, we have source, then after that we have runtime, then after that we have class. So if I talk about source policy, okay, the annotation which is going to have the source policy, okay, it is going to get discarded during compilation. Okay, so whenever I am defining an annotation with the retention policy of source, okay, this source, it is a retention policy. Okay, then that particular annotation which is declared with this particular retention policy, it is discarded during compilation. Okay, so it is not going to be accessible during runtime. Okay, then after that, annotation with class policy, it is stored in class file, but not during runtime. So actually here it should be not during runtime. Okay, so what I mean by this particular statement is that annotation which is declared with the class policy, okay, it is stored in the dot class file. Dot class file means the byte code, but it cannot be accessed during runtime. Okay, so here it should not be not, okay, but not during runtime. Okay, so there is a I did not write that not here. So you need to read this particular point as annotation with class policy which is stored in class file but not during runtime. Okay, not during runtime. So whenever I'm declaring annotation with class policy, it cannot be accessed during runtime. Then after that we have annotation with runtime policy, and this particular annotation, it is available during runtime. Okay, so this is how we are going to write the retention policy. Okay, first of all we are going to write at the rate retention, and another thing to remember is that this at the rate retention, this itself is a kind of a annotation. Okay, it sounds confusing, right? But that is actually what the case is. At the rate retention itself is a kind of annotation only. Okay, and inside this you are going to write retention policy. Okay, so here I think you need to write retention policy dot source dot runtime dot class, like that. Okay, so that is what this particular policy, retention policy, is going to do. Then after that we have runtime reflection. Okay, so if I talk about the concept of reflection, okay, during runtime, we can find out, what are the classes, what are the methods defined in a particular class. Okay, what are the how many constructors a class has, etc. Okay, so these are all the methods. We can even find out what is the fields which are present inside a particular class during runtime. Okay, all of these are going to happen during runtime. That is why we are going to call it as runtime reflection. Okay, so whenever we are collecting a class info, okay, during the runtime, then it is known as runtime reflection. Okay, obviously if I talk about class info, then I was talking about the methods, I was talking about the fees, I'm talking about the constructors. Okay, so all these are nothing but class info, and I'm collecting these during runtime. All right, and there is a API, defined for specifically by Java for this purpose, and it is defined inside java.lang.reflect package. Okay, so this particular package you need to import before you're trying to use these methods. Okay, then after that, if you want to get the object of a class. Now one thing you need to remember is that class. Okay, this C with class with C capital, this is a class which is defined in the Java programming language. Okay, so if you want to object, if you want to obtain the object of this particular class, then you need to use this particular method get class. All right, then after that, if you want to get the object of the class method, okay, method is also a class defined in Java. Okay, it is defined inside java.lang.reflect package. Then you can access it by using get method. In much the same manner, you can get the field. Okay, and get constructor to get objects of class field. Okay, and get constructor is for getting object of constructor, and get annotation is also which is a method which is defined in the class, and it is going to object obtain the annotation of a particular object. Okay, so these things obviously they will not be clear here because I am not using the IDE, but when I use the IDE, these methods and these concepts will get more clear. Okay, so now I am going to go to the next part, obtaining all annotations. Okay, so these are these this is one of the method which we can use for obtaining all annotation. So get annotation is the name of the method, and it is going to return return type. It is going to have a return type of annotation, array of annotation. Okay, then this particular thing, this particular method, it is defined in class, constructor, field, and method. Okay, so in that manner you can obtain all annotations or which are defined in a class or a constructor or a field or a method. All right, then after that we have this particular interface which is named as annotated element interface. Okay, so this particular interface, it is defined inside the java.lang.reflect package. Okay, so this is the package in which this particular interface is defined, and this particular interface it has these two methods. So first of all, the return type of this method is array of annotation, and the name of the method is get declared annotation. Okay, so it is going to return the list of declared annotations. Okay, so then after that, it is this particular method, it is going to check whether annotation is present inside a object of a class. Like here I'm giving the it is accepting the parameter of object of a class. Okay, so it is going to check whether annotation is present inside that particular class. So then after that we have the default value. Okay, so whenever we are creating an annotation, we can provide a default value for this particular methods. Okay, like here I'm writing type member. Okay, now one thing which will be surprising is that you are declaring this in the form of a method only, but even after that you can write the default, then after that you can provide the value. Okay, so even though they are kind of declared like methods only, but actually they are kind of variables only. Okay, so the default variable of the str, it is testing. Okay, and the default value of this val, it is 9000. Okay, so that is how the concept of annotation is designed in Java. Okay, so in the annotation, if I'm declaring a type member, it behaves like a kind of a variable only. Okay, so that's all I'm going to talk about in this particular tutorial. So if you have any kind of doubts or any kind of questions, then don't forget to post in the comment section below, and I will get back to you when I can. And if you liked this particular tutorial, then don't forget to like, share, and subscribe. And yeah, I will see you in the next tutorial. So till then, bye.